Kosso Ngu, Odilon, Alexander. Welcome to the Ngu School. Today we're going to be talking about intelligence and how we can use the sort of philosophical redefinition of intelligence and apply this to our everyday systems and optimize these systems for the benefits of us, our society, our environment. The first misconception about intelligence is is that intelligence nowadays is looked at from a very productive perspective. What do I mean by that? I mean that when we study intelligent systems, the strategy that we go by exploring these systems is to essentially zoom into the systems as much as possible so that we can understand and map out the different sort of complexities in the system. And this perspective has blinded us from a more universal, unified perspective of intelligent systems. And I keep using the phrase intelligent systems. What do I mean by intelligent systems? I believe intelligent systems are all systems, whether it be biological system, whether it be a mechanical system, whether it be planetary system, whether it be social system. So intelligent system is goes beyond physicality or dimensionality. All intelligent systems, all systems are intelligent systems, or are a subset of intelligent systems. So I believe that if we're able to model this unified system, then we'll essentially have the algorithm of how all the other systems within these intelligent systems work. So an example will be the ability for us to model the planetary systems, the movements, as in Einstein, relativity equations, energy equation, energy equal to the mass times the speed of light square. Our ability to model chemical systems, our ability to model biological systems, our ability to model social political systems, right? So essentially there is some underlying principle, there is some underlying algorithm that governs all systems. And for us to be able to find this algorithm, we're going to have to unify all systems. So our redefinition of intelligence is to redefine intelligence as more of a deductive perspective where we unify all the systems and find out the similarities and what makes all the systems work in tandem to each other. Not to zoom into one system by itself to study that, right? Of course, you're going to be able to model that system in its constraints within the boundaries of that system, but then the model breaks down and you go to other systems that are more complex or less complex. So essentially there should be some underlying principle to model the system's interaction and the system's state. In topology, it's proven that all systems can be modeled as point particles or spheres at the fundamental level, that's in higher dimensions. In lower dimensions, those spheres can be modeled as a unit circle. So really at the fundamental level, we can model all systems as unit spheres or unit circles, depending on the dimensions that you are looking at it from. And when we actually study the sphere and study the unit circle and study the transition between dimensions from 0 dimensions to higher dimensions like the second, third, and fourth dimension, we see that there is a unique property in all intelligent systems. What is this unique property? We see that intelligent systems have this dualistic aspect of them where they evolve in a discrete manner and they also evolve in a continuous manner simultaneously. So essentially, to imagine this in a topological way, imagine a sphere that is growing thicker, the same way that it's growing thicker outside, while it's simultaneously growing thinner inside. So essentially, this dualistic aspect of the growth creates this balance that allows the system to keep itself perfectly balanced as it transitions between dimensions. And when this was proven topologically with the Poincaré conjecture, which is proven by this mathematician or academic eccentric guy known as Gregory Perman, they showed that topologically the sphere was sort of the fundamental shape of all systems. And recently it was proved by some other mathematicians that we can actually go from lower dimensional space to higher symplectic space, four-dimensional space, going from unorientable systems like the Mobius strip to more complex higher dimensional systems like the Klein bottom. So essentially, this proves that systems have a discrete nature to them, and also have a continuous nature to them. And these systems include all systems, whether it be biological, chemical, astronomical, celestial, whatever system, whatever perspective, whatever frame you look at it from. This property is persistent throughout all systems. The symmetry is persistent throughout all systems. This dualistic aspect of the system means that time itself is dualistic, as in time flows forward and time also flows backwards. So essentially, for us to redefine intelligence, we have to essentially go to an understanding that all systems operate at a fundamental level in a dualistic way. And once we have this understanding, we can now model our systems to grow more efficiently, because we understand that there has to always be a growth function and a stability function.